All right, so, if a function's continuous, is it differentiable? Not necessarily. It can be, but not necessarily, because maybe we have like the way that my freshman graph trig function, big pointy mountains. It's not continuous, or sorry, not differentiable at all those corners, but it is continuous. If a function's differentiable, is it continuous? Absolutely. And this is a big thing AP will ask you, is on one of those free response questions, and I am an AP grader and been an AP grader for 6 years, and I've graded maybe 8 different problems. I grade thousands of these same questions. And 3 of those 6 years, I've gotten this question, where they say, you have a differentiable function that goes from, Milo, pick a number.
4.
Other Milo, pick a number.
7.
Ben, pick a number.
6.
Okay. So our differentiable function goes from here to there. And they will ask something like, oh. Does that have to be true? And you guys will know the answer, and you will not write it in a way that AP likes. So what is the answer?
Yes.
Yes, because
If it's continuous, that means it'll hit every point in between
okay,
points.
so intermediate value theorem, if the function's continuous, going from 4, a y value of 4 to a y value of 6, you had to go through 5, which is what I would say as well. And they would not give you credit. Because I didn't tell you it was continuous. What did I tell you?
It was differential.
That it's differentiable. So you need to say, because it's differentiable, jerks, it's continuous. Like I feel bad for you guys on these questions, and I go back and forth with the table leaders, and one question, it was a matter of where they put the comma in their statement of, are they saying that it's differentiable, therefore it's continuous, or it's differentiable and continuous? Yeah.
So wait, when you're grading, do you grade the same question for like?
Thousands of them for days, yes. 3 days, the same blasted question, and then it's like, woohoo! 3 or 4 days of a different same freaking question. Yeah.
What's the benefit of doing that?
Not a lot. I do quote unquote get paid. I can actually like buy a pizza now and then. You know, it's embarrassing that the teenager that works at the Trader Joe's, my neighbor, makes more than me when I do AP grading. But, you know, you're right. What's the benefit? Why would I do that? Because I get insight on when you guys ask, well, is this good enough? I can now more clearly tell you. I am getting better at predicting what they're going to do. So they changed some things this last year, and I'm like, what? But this has been a long time thing. If they tell you, here's a differentiable function, immediately say, because it's differentiable, it's continuous, and then you can make your like sensible conclusions that you would have given anyway, like, and get them right. So just putting that out there. They're a pain in the butt with this. So did you guys have questions on any of the textbook stuff or any Delta Math? And the Delta Math, the way they do product rules, they gave you superiorly ugly stuff that they didn't want you to expand out. For mine, I won't make them that bad, and you should expand out in the end. And if you don't have any explicit questions, I do want to check the homework, so can you take that out? but if you didn't do this one, or you did it, I would like you to check your answers with others nearby. Did you get a chance to do it?
No, I didn't know. I only did the document.
Okay. Well, was this signed 2 days ago? Day 10, the last one out of the text. This might be
I
a
got
couple
x
days ago.
equals -1.
This might be from day 1. And
I know I should have told you the other day, but is there any way we can do it today? I don't think they have to.
Last name.
Yeah, it's.
It was days ago that I signed it. I warned you guys yesterday that I was gonna check.
One.
Day 10, 3.
I wish I was not. Which one?
Yeah, it's the one through 31.
1 through 31. Right. Boom, 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 boom.
Okay, so some of you didn't do it, fine, but do try this problem. And I want to show you how AP would expect work to support your solution. So you need 2 equations to solve. Alex, how do I get one of those equations? To solve for A and B. I need to find, the question says, what is A and B that makes this thing continuous and differentiable?
One of them you do f of 1 for each equation, and second, or you would like assume continuity.
Okay, so for continuity to work, he says, as I approach 1 from the left, it needs to equal 1 from the right. And that needs to equal f of 1, which is defined. So plugging in 1 for x, so at the spot where we have the break, I get the answer to A. Their question for part A is horrible. Oh, if it's continuous, what is the relationship between A and B? They're asking you to, if it is continuous, this is what has to be true, yeah.
So you can like leave it, you can leave it like that, you don't need to like isolate one of the variables.
You can leave it like that.
Okay.
So, but I have two unknowns, I need two equations, how do I get another equation? Sam?
Take the derivative, and then you said the limit as x approaches 1 from the left of f prime of x is equal to
Okay, so what is the derivative?
-1, and then
For what x values?
sorry, for x is less than 1, and then it's 2a plus 2ax plus b, x is greater than 1. Wait, but I have a question, just because since we know it's going to be both continuous and differentiable, can we put the greater than or equal to
Okay.
already, or should we still
So,
wait?
they are telling us make it, force it to be continuous. I always wait to the end, but I forgot to go back and do that in first period. So, we'll do it now so that I don't forget. So this is the neat way to say what is the derivative of this piecewise function. I need all the bits to it. What is the function and what x values does it work for? So he says we now need to check the derivative from the left. Does that equal the derivative from the right? Which does that equal the derivative at 1? So -1, now plugging in the 1, I get 2a plus b. All right, and now systems of equations. You guys can choose substitutions, so Ben, you could go through and solve for one letter or the other. I personally am going to take this equation, multiply it by -1, and copy it over here to get 1 minus 2a minus b, and I'm going to add straight down to get a is -3. And then going back to either equation, plugging in -3 for a, I get b is 5. So those are the two values that would be required to make this function continuous and differentiable. Yes?
So on the AP exam, do they care if we do like the adding thing to find the variable, or can we do the
You can do
point?
substitution. You can do substitution or linear combination. I have a preference to linear combination because substitution, I will distribute something wrong somewhere along the time. So that's a thing for you guys to know your own personal working weaknesses, like to avoid negatives, maybe you add it to the other side, or I don't know. Wherever you have an issue, short circuit something. Can we look at 15? So I did say do product rule without doing the distribute, and I didn't mean that for this case. Like, this I see as quotient rule is the big one. Did any of you do this one?
Is that from the homework?
It might have been on the homework that I replaced with Delta Math.
No, this was on.
This was on the old, the
district.
one you just checked.
Okay,
Yeah, this is.
so,
You did do this one.
all right. There are ways to do this, but goodness, if we do quotient rule with this right now, the derivative of the top is got a product
It's
rule
bad.
and it's a mess, it's bad. So, but you know, Algebra 2 and pre-cal happened, I know what this is multiplied out. X times x squared, x times x times 1, minus x squared, minus x, minus 1, don't lose the denominator. Then let's see, x squared, negative x squared, positive x, negative x, Ow. Okay, so sometimes the answer is do the algebra first. Do algebra 2. And I'm still not done. I still haven't done the derivative yet, but I'm gonna do one more thing. And I call this technique divide and conquer. We will do this a lot. Anybody got a guess from the name? What am I gonna do?
Like split it into x3 over, like x power 3 over 3 minus 1 over x power 3.
So split the numerator up and reduce things. That's what I mean by divide and conquer. I still haven't done the derivative, but oh my God, that little bit of algebra. What's the derivative of 1? 0. What's the derivative of negative 1 x to the negative 3? Well, multiply by the power, lower the power. Done. And some of you will insist on using quotient rule here. Well, that one's not that bad. I'm not gonna do quotient rule from there, forget that. But bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. What is x cubed squared?
X to the 6th.
Okay, and don't leave it like this. Three x to the 5th minus 3x to the 5th. Those guys reduce, and I get 3x to the 4th. 3 over x to the 4th, yes.
Could you also, like, when you have it as y equals x cubed minus 1 over x cubed, could you also just turn the bottom x cubed, so like times x to the negative 3 and then do product rule?
It will work for this one. And that's what quotient rule, that's why quotient rule is what it is, that over the other thing squared, yes. But you can't do that for all situations yet. We need to get to 3.6 and then that rule will generalize, but it doesn't yet. Sophia, pick a number.
7.
Alana?
I need to have the club there.
Oh, wow, is that already down?
It's
Okay.
at 11.
Okay, so yeah, guys, those of you that need to go to the public fair, this is just a review of whatever you had questions on, and to show you other things, but it's nothing that you wouldn't know. Jessica, pick a number. 16. So if I wanted to do the derivative of this, would I do quotient rule or something else? Something else? What's the something else? Power rule. Bye, guys. Have fun clubbing in a high school kind of way. Okay. And I'm gonna cheat and change the 7 to a 2 because I don't feel like doing 7 times 16. Okay. If I was to do quotient rule, bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That becomes negative 32 x to the 15 over x to the 32, subtracting the exponents. I get that. All very clubby. But those that said, do the something else, do the power rule. Multiply by the power, negative 16 times 2, lower the power, much faster. Like, don't waste your time. When this is a constant, don't waste your time. I want to make sure that you guys can do these things. Did you do okay with the stuff. Yeah.
So the 121, I think it was like prove that d over dx is equal to c times d over dx f of x. I was confused on how it like you like separated it and then you canceled out one of the derivatives. Like it was equal to 0.
Oh,
Oh, wait, never mind.
It was a
'cause
constant.
constant. Okay.
right. Okay, but to go back to these guys. You will see these on Delta Math and you will see them on like a quiz, on a test. So what this is asking is do the product rule. UV prime plus V U prime, and just to show you some notation that I will use throughout the year. This is asking us to evaluate this problem at x equals 0. That's straight bar on the right side, and the little x equals means evaluate the thing that you just found at 2, or sorry, at 0. U of 0 is 5. V prime at 0 is 2. V of 0 is -1, and U prime at 0 is -3. And I get 13. Good? And D, it's 7V prime minus 2U prime, and then evaluating at 0, 7 times 2 minus 2 times -3 to get 20. How would you do that? If g of x, you don't know anything about g of x except that at 2 it's -1 and its slope at 2 is +4. How would you find the derivative of that? Try it, talk to the people next to you.
Wait, Ms. Pascal, just
Yep.
a quick question, is that like y equals g of x times 2x cubed? minus-
Yes.
Okay.
meta showing work. On quizzes and tests, I really, really, really recommend, and sometimes I actually demand, that you show me this. Symbolically, what is the derivative in terms of x? So, product rule, first times the derivative of the second, plus second times the derivative of the first, all with x's in it. Down here, I'm saying I'm now going to evaluate that derivative at 2. So g of 2, I declared was -1, plugging in 2 for the x. 2 squared times 6 is 24. Then 2 times 2 cubed minus 1 is 15. Okay, and so I get 60 minus 24, 36. What I've seen students do is they do this. They'll plug in 2 for some parts, x's for other parts, and then it's a Frankenstein. If you do this with the 2's in there, it's wrong. Because that's not the slope everywhere, that's the slope at 2 only. So you're declaring the general slope is blah, blah, blah with this Frankenstein thing. And you'll end up getting the right answer in the end, but your statement midway is wrong. Questions? Yep.
I have a question about 23.
Okay.
So you can just like split it up and like make it more simple, like 7 times the derivative of v and then subtract it.
Mhm. That's what those, can I clear this stuff? That's what those rules were that I granted went quite quickly over. That it said y equals c times a function. The derivative we can say is c times, and the way I had you guys do that, I'm like, oh, y equals 5x squared. What is dy dx? You just did 10 times x. You just you did power rule with the coefficient that was out there. So this is 7 times the derivative of whatever u happen to be, or v happen to be. Did you guys have any questions on any, like, I am picking the ones that first period had asked, and places where I was like, oh, this might be tricky. We did the system, piecewise stuff. No one asked, but that one, if we needed to do the derivative, you would have to like multiply it out. Otherwise, you'll get it wrong if you try and do power rule. And you won't understand why yet, unless you already had calculus. Asking you to graph some things, given what they look like. Wrong correction. And when does Club Fair start?
11:20.
20, so soon enough. Okay. Ooh, there was another thing I needed to show you. On the test, some of you picked an option that made me think that, do you know that it's allowed to cross the horizontal asymptote, the functions? Like, if they told you in elementary school that's not okay, then, well, here's this. Very clearly, the horizontal asymptote is riding off to the sunset at a height of 0. Here it crosses the horizontal asymptote so much that it's solid. It has its wild and crazy teenage years. It dances over the horizontal asymptote a whole lot. And that it settles down, gets a dog, buys a house, and rides off into the sunset. Calm, cool, and collected at the height of 0. Right. Yeah. So, totally allowed to cross the asymptote. All asymptotes mean is at the end of time or beginning of time, the y value is predictable. You're still allowed to have your wild, crazy teenage years before you get a house and a dog. Or llama, I don't know. Whatever your animal preference might be. Okay. Anything else? Today's like the freebie catch-up day, catch your breath kind of thing, but looking to fix any other questions that are still out there. And one person turned in test corrections. I don't require corrections for tests, and there's if you would like the feedback, I can collect them and check them over. But I don't require you to turn in test corrections. But if it really didn't go well, you should come in and we should talk it over and see what happened so that it doesn't happen again. And I do give fairly detailed feedback on the tests themselves. Like, you should look at it. Am I like yelling at you at how you wrote your work, or like your process, or is it just that you did some arithmetic wrong? Like, where are the mistakes? What kind are they? And that'll be more important in chapter 3. One student last year was like, yeah, I didn't understand derivatives at all. That's all of chapter 3, and didn't care to go back and learn it. And now in like February, I'm really unhappy that I did that. We use derivatives for the rest of like here forward, including like if you're going to Calc 3 or whatever, derivatives, you need to know them. So make sure you get your quotient rule correct. That's why it was on Delta Math. It would stop you and fix you, redirect. All right, I don't know. Anything else? No? Okay.